Hello students. So we were discussing the Ncert questions from the chapter Chemical Reactions and Equations. So in my previous video already we have discussed some of the questions. So today we will discuss some more questions from our exercise. So the first question is, which of the following statements about the reaction below are incorrect? We have to find out the incorrect statement or the incorrect option. So this is the reaction is given. Lead oxide reacts with the carbon. They form the lead and the carbon dioxide. So the first option is given. Lead is getting reduced. So this is the example of the oxidation and the reduction reaction. So we have to find out what are the substances getting reduced and what are the substances getting oxidized. And we have to find out the incorrect statement. First, what is the first option is given? Lead is getting reduced. So if you look at the reaction carefully, here the lead is not getting reduced. Here the lead oxide is getting reduced. See, lead oxide, PbO. So the oxygen, this lead oxide lost one electron and it became lead. So this option is incorrect option. Lead is not getting reduced. Lead oxide is getting reduced. Next option is carbon dioxide is getting oxidized. Here you see the carbon dioxide is not getting oxidized. The carbon is getting oxidized. Carbon by gaining one electron, it became carbon dioxide. So carbon dioxide is not getting oxidized. This is also incorrect option. Now the third option, carbon is getting oxidized. It is correct. Carbon by gaining one electron, it became carbon dioxide. This is the correct option. Lead oxide is getting reduced. So just now I told no, the lead oxide is getting reduced. The lead oxide, from this lead oxide, by losing this oxygen, lead oxide became lead. So this option also correct option. So according to this question, we have to find out the incorrect statement. So which are the incorrect statements? The options are given A and B, A, C, A, B, C and all. So which option will be correct? The option 1. So this statement A and the statement B are the false statement or the incorrect statement. Okay, now let's see the question number 2. So iron oxide reacts with aluminium. They form aluminium oxide and the iron. So the above reaction is an example of a combination reaction, double displacement reaction, decomposition reaction and the displacement reaction. So here clearly we can see the iron oxide reacts with aluminium. Now, aluminium is more reactive. In the reactivity series, aluminium is placed above the iron. So, aluminium is more reactive than the iron. So, aluminium easily can displace this iron. And they formed what? Aluminium oxide plus iron. Since in this reaction, the aluminium replaces the iron. So, that is why it is an example of the displacement reaction. So, see, if you look at the reactivity series also, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. So see, in this reactivity series, the aluminium is placed above the iron. So iron is more reactive than the iron. So that is why iron easily could displace this. This aluminium easily could displace this iron. So that is why it is an example of the displacement reaction. Now let's see the third question. What happens when dilute hydrochloric acid is added to iron fillings? So hydrochloric acid formula is HCl. When the hydrochloric acid reacts with the iron, then what they will form? So see, in the reactivity series, iron is placed above the hydrogen. So iron easily can displace this hydrogen and they will form FeCl2, that is iron chloride. Along with the formation of the iron chloride, there will be formation of hydrogen gas. So when the dilute hydrochloric acid reacts with the iron fillings, they form iron chloride and hydrogen gas. So which option will be correct option? That is the option A. Hydrogen gas and the iron chloride are produced. Okay, now let's see the question number 4. What is a balanced chemical equation? Why should chemical reactions be balanced? Okay. For example, if I write equation magnesium plus oxygen, they form magnesium oxide. Now, if you look at the equation, this is called reactants. The left hand sides are called reactants and the right hand side is called the product. So balanced chemical equation means that the number of atoms in the reactant side should be equal to the number of atoms in the product side. But if you look at this equation, here you see in the reactant side, how many atoms of magnesium is present? 1. Here how many? 1. So magnesium is balanced. Oxygen here how many? 2. Here oxygen how many? 1. So oxygen is in the unbalanced state. So this kind of chemical equation, it is called the unbalanced chemical equation, or it is also called skeletal equation. So what is balanced chemical equation? So balanced chemical equation means the number of atoms in the reactant side should be equal to the number of atoms in the product side. Then the reaction is said to be, or then the equation is said to be balanced. Now the next part of the question, why should we balance the chemical equations? So from the law of conservation of mass, we know that mass can neither be created nor be destroyed in a chemical reaction. For example, in this reaction, if I take 2 gram of magnesium and if it is reacted with the 5 gram of oxygen, then I will get the product magnesium oxide, and the mass of the magnesium oxide will be 7 gram. So in a chemical reaction, mass can neither be created nor be destroyed. Mass of the reactants always will be equal to the mass of the product. So to satisfy the law of conservation of the mass, a reaction should be balanced. So what do you mean by balanced chemical equation? So answer is, if the number of atoms in the reactant side is equal to the number of atoms in the product side, then the equation is said to be balanced. Now the next part is, why should chemical reactions be balanced? So chemical reactions should be balanced to satisfy the law of conservation of mass. So to satisfy the law of conservation of mass, a chemical equation has to be balanced. So what is a balanced chemical equation? If the number of atoms in the reactant side is equal to the number of atoms in the product side, then a chemical equation is said to be balanced. Why should we balance the chemical equations? To satisfy the law of conservation of mass. Okay, now let's see the question number 5. Translate the following statements into chemical equations and then balance them. So here, according to this question, some chemical reactions are given in the statement form. First, we have to convert into the chemical equation. Chemical equation means what? This statement we have to write in their symbolic form. So after writing in the chemical equations or after writing in the symbolic form, we have to balance them. So what is the first question? hydrogen gas combines with nitrogen to form ammonia. So hydrogen symbol is H2. Hydrogen combines with nitrogen N2 and they form what? Ammonia. Now this reaction is called the skeletal equation because it is in the unbalanced state. Here you will see in the reactant side hydrogen is 2 but in the product side hydrogen is 3. In the reactant side nitrogen is 2 but in the product side nitrogen is 1. Now to balance the chemical equation don't use the heat and trial method. So always this trick remember. Whenever you are going to balance the chemical equation, first try to balance the metal, then try to balance the non-metals, then oxygen and then hydrogen. This trick always remember. Don't use the heat and trial method. Though oxygen and the hydrogen also non-metal, but oxygen and the hydrogen try to balance at last. Oxygen second last and the hydrogen at last. Always try to balance the hydrogen at last. Now look at this reaction. Here metals are absent. So metal no need to balance. Then non-metal other than oxygen and hydrogen. So which one is the non-metal? Nitrogen is the non-metal. Here nitrogen how many is present? 2. Here nitrogen is how many? 1. So this side hydrogen is less. So put 2 here. Now again start from the beginning. Metals are not there, non-metals. Nitrogen 2, nitrogen 2. Now oxygens are absent. Now try to balance the hydrogen. This side hydrogen how many? 2. This side hydrogen how many? 3 2 are 6. These 3 and 2 will be multiplied. Here the hydrogen will be 6. This side how many? 2. So put 3. Now you check. Now you count the number of atoms in the left hand side and the right hand side. So hydrogen this side 6. This side hydrogen 6 balanced. Nitrogen this side 2. This side 2. So the reaction became balanced. Now the next question. Hydrogen sulfide gas. Hydrogen sulfide formula H2S. Hydrogen sulfide burns in air. Burns in air means what? It reacts with the oxygen to give water H2O plus sulfur dioxide SO2. Now to check the reaction is in the balanced or unbalanced state. Hydrogen 2, hydrogen here 2. Sulfur 1, sulfur 1. Oxygen here 2. This side oxygen 1 plus 2, 3. That means the reaction it is a skeletal equation. So this skeletal equation we have to convert into the balanced chemical equation. So trick always remember first metals, non-metals, oxygen and the hydrogen. So in this reaction also metals are absent. Then non-metal other than oxygen and the hydrogen. So which one is the non-metal? Sulfur is the non-metal. But here sulfur in the left hand side 1, here also right hand side 1. Then try to balance the oxygen. So here you see oxygen 2, here oxygen 1, 3. Here oxygen how many? 2. So this side oxygen is less. Left hand side oxygen is less. So put 2 here. Now check. Metals are absent, non-metals only sulfur. This side sulfur 1, sulfur 1. Now you see oxygen this side became 4. This side became oxygen 3. Now this side oxygen became less. So try to balance right hand side. So put 2 here. Now after putting the number always start from the beginning. Metals are absent. Sulfur now check. Sulfur this side 1, this side 1. Sulfur balanced. Now oxygen 2 to the 4. Here 2 oxygen plus 2 oxygen 4. Now count the hydrogen. So here hydrogen how many? 2. Here hydrogen how many? 4. Now the hydrogen became unbalanced. So this side hydrogen is more. This side hydrogen is 4. This side hydrogen is 2. So now try to balance the hydrogen. So put 2 here. Now again start from the beginning. Metals are absent. So whenever you are putting the number always start from the beginning. Check start from the metals. So here metals are absent. Then if metals are absent then non-metals. Now check the non-metals. See this side sulfur 2. This side sulfur is 1. So put 2 here. Okay, now again start from the beginning. Metals are absent, sulfur 2, sulfur 2. Now count the number of oxygen. Here you see 2 to the 4 oxygen because these two will be multiplied. So 4 oxygen plus 2 oxygen. So right hand side 6 oxygens are present. Left hand side how many? 4. So this side oxygen is less. So write 3 here. Now you see left hand side oxygen became 6. Now check the hydrogen. Hydrogen 2 2s are 4. This side hydrogen 2 2s are 4. Now the reaction became balanced. So instead of applying the heat and trial method, always follow this track: metal, non-metal, oxygen and hydrogen. Okay, now let's see the question number C. Barium chloride reacts with aluminum sulfate to give aluminum chloride and a precipitate of barium sulfate. Now, barium chloride formula is BaCl2. Barium chloride reacts with aluminum sulfate. Aluminum sulfate formula is Al2SO4 3. So why the aluminum sulfate formula is Al2SO4 3? See, aluminum symbol is Al and the sulfate is SO4. The valency of aluminum is 3 and the sulfate is 2. Now crisscross. So the chemical formula of aluminum sulfate will be this valency of this will go with aluminum and the valency of this aluminum will go with sulfate. So that is why the formula of aluminum sulfate is Al2SO4 3. So barium chloride reacts with aluminum sulfate to give aluminum chloride. Aluminum chloride formula is AlCl3. Along with the formation of the aluminum chloride, they will form a precipitate of barium sulfate. Barium sulfate formula is BaSO4 and they will form one precipitate. So this arrow means what? This is an insoluble solid or precipitate. Now it is a skeletal equation. We have to balance this equation. So just now I told no trick. Always try to first balance the metal, then non-metal, then oxygen, and at last try to balance the hydrogen. First identify which are metals. So see, barium is the metal, aluminum is the metal. Now check. Barium left hand side 1, right hand side 1. Barium is balanced. Now check the aluminum. Aluminum 2, here aluminum 1. So aluminum is less. So this side put 2. Now see, metal became balanced. Barium 1, barium 1. Aluminum 2, aluminum 2. So the aluminum also became balanced. Now after the metal, next is non-metal. So identify the non-metal other than oxygen and hydrogen. So here chlorine is the non-metal, sulfur is the non-metal. So chlorine this side how many? 2. This side chlorine how many? 3 2s are 6. This side chlorine is more. So try to balance this side. So put 3 here. So this will become 3 2s are 6. So whenever you are putting the number, always start from the beginning, that is from the metals. Again check, start from the metals. This side barium is 3. This side barium is how many? 1. So put 3 here. Now check the aluminum. This side aluminum is 2. This side aluminum is 2. So metals are balanced. Now check the non-metals. So chlorine this side 3 to the 6. 3 to the 6. Now check the sulfur. Here sulfur how many? 3. This 3 is common for both sulfur and the oxygen. Sulfur is 3. Here sulfur how many? 3. Now check the oxygen. 3 4 the, this 3 will be multiplied with the 4. 3 4 the 12. Oxygen left hand side how many? 12. Check right hand side. 3 4 the 12. So oxygen also balanced. So in this way, instead of applying the heat and trial method, apply this trick. MnOH. Metals, non-metals, oxygen and then hydrogen. Next you see potassium metals reacts with water. So potassium formula is K. Potassium reacts with water to give potassium hydroxide KOH and hydrogen gas. Now you balance, this is a skeletal chemical equation, balance the equation. So this side potassium, first metal, potassium 1, potassium 1. Then non-metal other than oxygen, hydrogen. So non-metals other than oxygen and the hydrogen are not there. Now try to balance the oxygen. Oxygen here how many? Oxygen 1, oxygen 1. Then at last always try to balance the hydrogen. So this side hydrogen how many? 2. This side hydrogen how many? 2 plus 1, 3. So this side hydrogens are more. So the side where the number of atoms are less, that side first try to balance. So hydrogen 2, so put 2 here. So whenever we put the number, always we start from the beginning, from metals. Metal 1 means potassium 1, this side potassium 1. Then non-metal. So non-metals other than oxygen and hydrogen are not there. Then oxygen. This side oxygen 2, this side oxygen how many? 1. So this side oxygens are less. So put 2 here. Now again start from the beginning. Check from the metals. This side metal 1. This side metal became now how many? 2. So put 2 here. So potassium 2, potassium 2. Now check oxygen. This side oxygen 2, this side oxygen 2. Now count the hydrogen. 2 to the 4. Here 2 hydrogen. 2 hydrogen plus 2 hydrogen, 4 hydrogen. Now the reaction became balanced. So in this way we can balance any type of chemical equation. Okay. Now let's see the question number 7. So this question number 7 also related to balancing the chemical equations. So here word equations is given. First we have to convert into chemical equations, then we have to balance. Now here the compound name is given. First we should know how to convert this compound name into the chemical formula. So calcium hydroxide. Formula of calcium hydroxide is CaOH2. Calcium hydroxide reacts with carbon dioxide CO2. They form calcium carbonate. Calcium carbonate formula is CaCO3 plus water. So first you have to convert the word equation into chemical equation, then you have to balance. Now try to balance. So first try to balance the metal. So identify the metal. So calcium is the metal. So calcium left hand side 1, right hand side also calcium 1. Now try to balance the non-metal other than oxygen and hydrogen. So see, which one is the non-metal? Carbon is the non-metal. So carbon this side 1, this side also carbon 1. Now try to balance the oxygen. Now check the oxygen. This side oxygen how many? 2 plus 2, 4. Here 3 plus 1, 4. So oxygen also in the balanced state. Now check the hydrogen. So hydrogen here left hand side 2, right hand side also hydrogen 2. That means the reaction is already in the balanced state. Now the next reaction. Zinc reacts with silver nitrate. Zinc reacts with silver nitrate. Silver nitrate formula AgNO3. It will form zinc nitrate. Zinc nitrate formula ZnNO3 2. So zinc reacts with the silver nitrate. They will form zinc nitrate plus silver. Now try to balance. First try to balance the metal. So see, left hand side zinc 1, right hand side also zinc 1. Left hand side silver 1, right hand side also silver 1. Now try to balance the non-metal. So see, nitrogen is the non-metal. So left hand side nitrogen 1, right hand side nitrogen is 2. So left hand side number of nitrogens are less. So this side 2, this side 1. So put 2 here. Now whenever we are putting the number, always start from the beginning, from the metal. Now check again from the metal. Zinc 1, zinc 1. Silver 2, this side silver 1. So put 2 here. So zinc 1, silver 2, silver 2. Now non-metal. Nitrogen 2, this side nitrogen 2. Now oxygen. So oxygen 3 to the 6. Here oxygen 3 to the 6. So then our reaction became balanced. Now question number C. Aluminium reacts with copper chloride. They form aluminium chloride plus copper. Now aluminium Al plus copper chloride. Copper chloride is CuCl2. They form aluminium chloride. Aluminium chloride formula is AlCl3 plus copper. Now try to balance. Here you see, aluminium is the metal, copper is the metal. So aluminium left hand side 1, right hand side 1, balanced. Copper right hand side 1, sorry, left hand side 1, right hand side also 1. Then non-metal chlorine. So this side chlorine is 2, this side chlorine is 3. Now first try to balance the chlorine. So how can you balance? So chlorine this side is 2. This side number of chlorines are less. This side number of chlorines are more. So if I put here 2 to the 4 will be. So here if I put 3 to the will be 6. So if I put 3 here. Okay. Now check. And 2 here. Now the chlorine will become balanced. 3 to the 6. Here 3 to the 6. Chlorine will become balanced. Now again, check from the beginning. Aluminium 1. Now this side aluminium became 2. So put 2 here. So aluminium 2, aluminium 2. Now check the copper. This side copper 3, this side copper is 1. So put 3 here. Now the metals became balanced. The non-metal chlorine 3 to the 6, 3 to the 6. So now the reaction became balanced. Now the last equation. Barium chloride reacts with potassium sulfate. So barium chloride formula is BaCl2. So barium chloride reacts with potassium sulfate. Potassium sulfate formula is K2SO4. They will form barium sulfate, BaSO4, barium sulfate. Along with the formation of the barium sulfate, they will form potassium chloride, KCl. Now try to balance. First try to balance the metal. So see, barium is the metal, potassium is the metal. Barium left hand side 1, right hand side also 1. Potassium left hand side 2, right hand side 1. So right hand side number of potassiums are less. So put 2 here. Now again start from the beginning. Barium 1, barium 1. Potassium 2, potassium 2. Now try to balance the non-metal other than oxygen and hydrogen. Chlorine is the non-metal, sulfur is the non-metal. So left hand side chlorine 2, right hand side also chlorine 2. Chlorine also balanced. Sulfur. Left hand side sulfur 1, right hand side also sulfur 1, balanced. Now oxygen. Left hand side oxygen 4, right hand side also oxygen 4. So that is the reaction became balanced. Okay, now let's see the question number 8. So write the balanced chemical equation for the following and identify the type of reaction in each case. So first we have to balance this chemical equation and then we have to tell what type of this chemical equation. So the first equation is potassium bromide. Potassium bromide, KBr, in aqueous form. So in this equation that state also given. That means this potassium bromide, this is the solution of potassium bromide in water. AQ means aqueous solution. Plus barium iodide. Barium iodide formula is BaI2. It is also aqueous solution. They formed potassium iodide, Ki. It is also aqueous solution. Plus barium bromide. It is in solid form. So first we have to convert into balanced state. Then we have to tell it is a kind of what kind of chemical reaction. So see, potassium bromide reacts with barium iodide, form the potassium iodide plus barium bromide. Now first try to balance the metal. So this side potassium 1, potassium 1, barium 1, barium 1. Now try to balance the non-metal. So what are the non-metal? Bromine is the non-metal, iodine is the non-metal. So see, this side bromine how many? 1. This side bromine how many? 2. So this side number of bromines are less. So put 2 here. Now again start from the beginning. First try to balance the metal. Potassium 2, this side potassium is 1. So put 2 here. Now potassium 2, potassium 2. Barium 1, barium 1. Now bromine, this side bromine 2, this side bromine 2. Then iodine, iodine 2, this side iodine 2. Now the reaction became balanced. Now we have to tell it is a kind of what kind of reaction. So clearly we can see, here you see, this ion took the place of bromine and bromine took the place of iodine. So it is an example of double displacement reaction. So what kind of reaction? It is a type of double displacement reaction. It is also the example of the precipitation reaction because here we will get the barium bromide which is in the solid form, which will be get in the form of precipitate. So it is an example of double displacement reaction as well as precipitation reaction. Next is zinc carbonate. Zinc carbonate formula is ZnCO3. Its state is given in S means solid state. So zinc carbonate breaks into zinc oxide. It is also in the solid form plus carbon dioxide in the gaseous form. So let's first balance this chemical equation. So first try to balance the zinc. Zinc is the metal. Zinc left hand side 1, right hand side also 1. Zinc is balanced. Then carbon. Carbon is 1, this side also carbon, 1 balanced. Now oxygen. This side oxygen is 3, this side 1 plus 2 is 3. That means the reaction is already in balanced state. Now we have to tell it is a kind of what kind of reaction. So clearly here we can see here reactant is 1. The reactant is broken down into 2 products. So if a single reactant breaks into 2 or more products, so it is a kind of what kind of reaction? It is a kind of decomposition reaction. So it is a type of decomposition reaction. Okay, now let's see the question number C. Hydrogen reacts with chlorine, they form hydrogen chloride. So this hydrogen is given in gaseous state plus fluorine Cl2. It is also in gaseous state. They form hydrogen chloride. Hydrogen chloride formula is HCl. It is also in gaseous state. So now first try to balance this chemical equation. So here metals are not there. Then try to balance the non-metal. So chlorine is the non-metal. So this side chlorine is 2. This side chlorine how many? 1. So here put 2. Now check. Metals are not there. Then chlorine 2 balanced. Now this side hydrogen 2, this side hydrogen 2. Now the reaction became balanced. Then we have to tell it is an example of what kind of chemical reaction. So here clearly we can see that 2 reactants they combined together and they formed a single new product. So it is an example of combination reaction. So it is an example of combination reaction. Now the question number D. So magnesium is given in solid state. Magnesium reacts with hydrogen chloride HCl. It is given in aqueous. Aqueous means aqueous solution of hydrogen chloride. They formed magnesium chloride. Magnesium chloride formula is MgCl2 plus hydrogen gas. So first we have to balance this chemical equation. So first try to balance the metal. So which one is the metal? Magnesium is the metal. So number of magnesium in the left hand side also 1, right hand side also 1. Now try to balance the non-metal other than oxygen and hydrogen. So which one is the non-metal? Chlorine is the non-metal. So left hand side chlorine is 1, right hand side chlorine is 2. So put 2 here. Again start from the beginning. Magnesium 1, magnesium 1. Now non-metal. Chlorine 2, chlorine 2. Now oxygen. So oxygens are not there. Now try to balance the hydrogen. So this side hydrogen is 2, this side hydrogen is 2. Now the reaction became balanced. Now we have to tell this is an example of what kind of reaction. So here you can see magnesium displaces this hydrogen. Magnesium took the place of hydrogen and they form the magnesium chloride. So since magnesium displaces the hydrogen, that is why it is an example of the displacement reaction. In the reactivity series also, magnesium is placed above the hydrogen. Magnesium easily can displace the hydrogen. Magnesium is more active element than the hydrogen. It is an example of displacement reaction.